The send-off of NASA's Explorer tests was like the beginning of an astounding excursion into space. It demonstrated the way that we can keep an eye on Earth as well as everything in our nearby planetary group and beyond. Even after 46 years, these marvelous space apparatus are still providing scientists new and shocking data about space. Although their memory is 3 million times smaller than that of our cell phones and they're multiple times slower than our fastest 5G web connection, these unbelievable tests still lead the way in exploring space. And now, Explorer 1 has already made an incredible discovery in interstellar space, one that challenges all that we assumed we knew about the universe. It found something so surprising that scientists are left scratching their heads. But what exactly did it find and how can it redefine our understanding of the universe? Let's find out. Background history. On an exceptional day, September 5, 1977, from a spot called Cape Canaveral in Florida, something astounding occurred. Explorer 1 began its journey into space, set off by a solid rocket called Titan. Only 15 days later, on August 20, 1977, Explorer 2 joined in, beginning its own adventure into the universe. Their main work was to examine the large gas planets in our nearby planetary group, like Jupiter and Saturn, and the moons around them. But guess what? These space explorers went much farther. They went way out into our vast region, breaking loads of records on their surprisingly long trip. They've been going longer than any other rocket ever, and they've gone farther from Earth than anything humans have made before. They even went into a place called interstellar space, which is like going into a completely different part of our world that no one explored before. These space trailblazers, Explorer 1 and Explorer 2, are more than 12 billion miles from us now. Still, they continue to amaze scientists with the astonishing things they're discovering there. And they've recently found something so startling that no one saw it coming. The Explorer twin tests have done some magnificent stuff over a long time back. They checked out the moons of Jupiter and Saturn and completely astounded scientists. People used to think these moons were boring and full of holes like our moon, but nope, they're buzzing with activity. Explorer 2 was the first of the twins to swing by Uranus in 1986, and just 3 years later, it zoomed past Neptune. But here's what's fascinating: it's the only space apparatus that has ever done that. As these rockets move forward with their amazing journey, NASA is doing some tricks to ensure they keep working. They turned off certain things they didn't need, like extra parts and heaters, to save power. That way, the space apparatus can keep going strong until at least 2030. For the scientists and engineers who've been part of this incredible journey from the beginning, it's a mix of happy and sad feelings. They worked hard, and now when they thought the Explorer missions were nearly done, an amazing discovery emerged from space data transmission and Explorer 1's revelation. The information sent back by Explorer 1 and its twin rockets had become a goldmine for scientists. They sparked lots of discoveries and got people excited about space. These are two rockets that were built extra carefully, like stable stages, so they could take clear pictures and gather data while zooming through space. Even before they reached the outer planets, their pictures were already blowing scientists' minds. Explorer 1 started sending pictures of Jupiter even though it was still far away from the planet. People at NASA's Jet Propulsion Lab got excited when they saw the first pictures of Jupiter's swirling clouds and the famous Great Red Spot. But the breakthrough came when the explorers found something amazing on Jupiter's moon Io. This moon, a lot bigger than Earth's moon, turned out to be the most active volcano in our whole nearby planetary group. The explorers together took more than 33,000 pictures of Jupiter and its moons. They showed how stunning Jupiter is and all the special landscapes on its moons. And before this recent and truly astonishing discovery, these twin rockets have been finding great things since they started their journey. Another big treat was finding out Jupiter has rings, although they're not very bright. This discovery made Jupiter even more interesting too. Explorer 2 found that Europa, one of Jupiter's 53 moons, has a thick icy shell more than 60 miles thick. These discoveries made scientists rethink what they thought about these distant things in space and got them curious about whether icy moons like Europa could be places where life could exist. As the explorers left Jupiter, they got a boost from the planet's gravity that acted like a strong kick, sending them towards Saturn. This kick was exceptionally significant because it helped them break free from the sun's force and keep going into space. Explorer 1 and Explorer 2 went their separate ways after that, heading to new places. Explorer 1 got close to Saturn's moon Titan, which has a kind of orange murky atmosphere around it. Scientists got curious about Titan's secrets, so they focused on its complex chemistry. Then Explorer 1 moved away from the other planets and started going beyond our planetary system. On the other hand, Explorer 2 had some stunning experiences too. In 1986, it flew by Uranus and found 10 new moons, adding to the total count. 3 years later, it reached Neptune, showing us the amazing things about this faraway ice giant. Explorer 2 even measured winds on Neptune going as fast as 1,000 miles per hour, the fastest ever on a planet in our solar system. When the space apparatus got close to Neptune, just 2,980 miles away, it gave us new and incredible details about this distant world. Neptune's biggest moon, Triton, turned out to be one of the coldest places in our nearby planetary group, with temperatures dropping to a freezing -391 degrees Fahrenheit. Triton also had these cool ice volcanoes that shot out nitrogen gas and icy stuff into its thin atmosphere. All these discoveries made us realize how unique and interesting the planets and moons in our solar system can be, even the farthest ones. Imagine a space adventure story, and one person who had a big role in pushing it along was the famous astronomer Carl Sagan. He was part of the team that took pictures for the Explorer mission, and he wanted to snap one last set of pictures before switching off the cameras. These pictures would be like a special gift for everyone on Earth, a last look at our home from far out in space. Sagan didn't give up, and it paid off. On Valentine's Day in 1990, Explorer 1 turned its camera back towards the interplanetary group and took 60 pictures. The most famous one is known as the pale blue dot. It was taken from 3.8 billion miles away, making it the farthest picture of our planet ever taken. In the photo, Earth looks small, like a pale blue dot in the vast space around it. Even after 40 years, these rockets are still out there, sending us valuable information from the farthest parts of space. Now, let's talk about something a bit old school. The Explorer tests use an old 8-track tape system. Yes, you heard it right, 8-track tapes were nothing to joke about during the 70s, and these tests are still using them. It just shows how smart the people who planned this mission were, ensuring these old tapes could still do the job. But why 8-track tapes, you may be wondering? Well, that's a story worth hearing. You see, in the beginning of exploring space, the kind of digital storage we use today was just starting out. So they needed something tough and reliable to store important data, and those 8-track tapes turned out to be the perfect choice. What's even more interesting is that the data on these tapes isn't just ordinary music, it's valuable science data about planets, moons, and space between the stars. Yes, these tapes hold the answer to some of the biggest mysteries in the universe. Now, ponder this: the Explorer shuttle faces extreme things like unexpected hot and cold temperatures, space radiation, and the emptiness of space. Yet these old travelers keep going strong. It's like sending your grandparents on an adventure in Antarctica, and not only did they survive, but they thrive. Why did the Explorer missions work so well? The Explorer missions had this amazing move called gravity assist maneuvers. Think of it like this: Explorer 1 and Explorer 2, two bold space pilgrims, were on a big mission to explore far out in our nearby planetary group. To reach these distant places and gather valuable information, they needed a little help more than just their engines. Here's where gravity assists come in, and it's like a space dance. Instead of just using their engines, these space apparatus did this cool celestial dance with some of the solar system's large planets. They used their gravitational pull like a slingshot to sling themselves forward, saving fuel and gaining the speed they needed to visit lots of different places. Now, let's go easy on gravity assist, also known as a gravitational slingshot. It's about getting some speed from a planet as the shuttle goes by. Imagine Explorer 1 swinging by Jupiter, a huge gas giant with a gravitational pull to match its size. The smart minds at NASA's Jet Propulsion Lab made sure Explorer 1 swirled past Jupiter at the right angle and speed. Jupiter's gravity pulled at the shuttle, making it go faster like a space power-up. But here's the fascinating part: there's an art to this maneuver. If Explorer 1 had approached Jupiter the wrong way, it could have been a space disaster, sending the shuttle way off course. Luckily, the NASA experts nailed it, and the celestial dance with the planets was a big success. The level of precision required is amazing, but guess what? The smart scientists and engineers who planned this astronomical dance didn't just get it right once, but many times. Thanks to these gravity assist maneuvers, Explorer 1 and Explorer 2 went on this amazing journey through the planetary system. Explorer 2, for example, got a boost from Jupiter and Saturn to zoom to Uranus and Neptune. These space moves played a huge role in getting the Grand Tour going. Without these slingshot maneuvers, the Explorer missions could not have possibly been as spectacular as they were. Explorer 1 made it to interstellar space, and Explorer 2 wasn't far behind. Thanks to the immensely precise gravity assists they mastered. Behind gravity assist is simple, but getting it done is complex. Explorer 2's Grand Tour required a lot of precision. If they missed any of those boosts, the whole mission could have gone wrong. But the people in charge were determined to get all the data they could. Efforts by scientists and astronomers to fully understand the concept of gravity assist led them to uncover something even more intriguing about the dark area of space. The Deep Space Network. Despite the Explorer missions using gravity assist maneuvers to explore space, there's another important thing that made everything work: the Deep Space Network (DSN). Think of it like a space phone line that kept us talking to our brave Explorer tests as they went into the unknown. Now, what exactly is the Deep Space Network? It's not as flashy as a spaceship, but it's important. The DSN is like a big company of radio dishes in different areas of the planet, like California, Spain, and Australia. These giant dishes, some as big as 70 meters across, act like space megaphones, helping us talk to rockets that are way out there. Let's get into its role in the Explorer missions. The Explorer tests, with all their cameras and sensors, were our eyes and ears in space. To understand the data they sent back and tell them what to do, we needed locations of strength for a system, and that's where the DSN came in. Imagine this: Explorer 1, going to the outer parts of our nearby planetary group, sends a message back to Earth. It's a weak signal, moving incredibly fast through space. When it reaches Earth, it's really weak, but the DSN's big radio dishes are ready to catch that weak signal. They lock onto Explorer's whisper and turn it into data that scientists can use. The DSN doesn't just catch signals, it also sends commands. You see, missions like Explorer are always changing. Scientists and engineers need to adjust their plans or tell the space shuttle what to do. They send these commands through the DSN, shooting them into space to reach Explorer. It's like a two-way chat between Earth and the farthest human-made things in space. Something amazing about the DSN is that it works all the time, 24/7, always listening for those distant signals. The Deep Space Network is like our space organization, not just a bunch of antennas. It keeps the stories of the Explorer mission going, even as the shuttles go far beyond our solar system, exploring the unexplored lands of interstellar space, the Oort cloud, heliosphere, and heliopause. Interstellar space is a bit easier to reach than the farthest end of our solar system. Imagine the nearby planetary group is a swell with a haze of comet-like things far away, kept intact by the sun's gravity. This Oort cloud could stretch halfway to the closest star, and it will take the Explorer tests around 300 more years to get near its edge. Now, when we talk about interstellar space, it starts where the solar breeze, a rush of charged particles and magnetic fields from the sun, ends. The solar breeze acts like an expanding bubble, forming something called the heliosphere. This is like a protective bubble around the solar system, carried by the solar breeze. Eventually, this bubble gets compressed by pressure from interstellar matter, forming a boundary called the heliopause. The boundary between our planetary system and interstellar space is called the heliopause, estimated to be quite a distance away. Once upon a time, some assumptions put it as close as Jupiter, but more accurate calculations in 1993 stated it's 100 times the distance from Earth to the Sun. Explorer 1 reached this boundary around 20 years after these calculations, identifying a rise in plasma density. Now, Explorer 2 reached the interstellar beach in 2018, but it saw no changes in the magnetic field. This was surprising, as theories expected changes tied to the Sun's 11-year cycle. The solar wind was strongest when Explorer 2 arrived, testing these predictions. As the explorers provide real data, scientists are refining their models of how the heliosphere interacts with interstellar space. In simple terms, our Sun left a hot, ionized zone and entered a partially ionized part of the galaxy. The hot zone likely formed when nearby old stars exploded in a supernova, heating the space and messing with nearby atoms. Picture it like the beach with waves and water swirling. It's a bit wild. Magnetic fields play a role in this energetic zone, not the smooth one scientists usually draw because of the heliosphere's influence on the space between stars. The explorers found lots of small changes near the heliopause, but not much difference in magnetic fields at larger scales. Eventually, the shuttles will leave this turbulent region and hit the pure interstellar magnetic field. Saying goodbye to these cool space apparatus won't be easy. Both Explorer tests still have working instruments powered by a system that channels heat from plutonium's decay into electricity. But the power output is coming around for watts per year, putting the team in crisis mode. It's fascinating to watch the Explorer explore space, but as they move on, we're getting ready to say goodbye. The Explorer tests will continue exploring, even if they can't talk to us anymore. Explorer 1 will drop by Proxima Andor, our nearby star friend, in a whopping 16,700 years. Explorer 2 will look up a bit later, in 3,600 years. After that, they'll circle the system for thousands of years. Way later, our Sun is gone and the heliosphere has vanished. All of this just for that one tiny pale blue dot we call home. It's like their cosmic adventure never really ends. The Explorer tests may still be out there, not too battered. They could possibly send a final message during their journey, but not on the radio and not by us humans. They have two records, like old school tech but cooler. These records are made of copper, have a shiny gold cover, and are wrapped with aluminum. Now, these records, nicknamed the Golden Records, have cool stuff encoded in their grooves. There's about 90 minutes of music, like Bach's Brandenburg Concerto No. 2 and Chuck Berry's Johnny B. Good. Plus, there are pictures of children, dolphins, artists, sunsets, and sounds of crickets, rain, and a mother giving her child a kiss. Even Jimmy Carter, the president when the Explorer set off, left a message. It says, "We cast this message into the cosmos." It's a note saying hello. We hope that someday, after we solve our problems, we can join a community of civilizations out there. This record is like a message of hope and goodwill from Earth to the vast and beautiful universe.